You see it?
No.
Can you see it?
No, he's asking, did you add me inside the broadcast after you started it? How do you do that? Oh, I need to add him. I did that, but before it was okay.
Invite me. I'll see if I can do it. Put your last name on it.
96.
Mm.
Oh, there he is.
Hi.
Hi, Pierce.
Hopefully this is recording.
Yes, it is.
Awesome.
Perfect. Okay. How are you doing?
Doing good, doing good. Just got back from watching Guardians of the Galaxy 2.
Okay. Is it good?
It's great.
Oh.
I love movies that don't take themselves seriously most of the time.
Mm-hmm. That's great. Thank you so much for doing this.
Oh no, not a problem.
Yeah, I was a little bit confused. I started working on part A. But I don't know if I was doing it right. So what I was doing is I calculated I used the expected income formula for 2013, and then I used the expected income formula, but instead of doing sub age, I did the thing that they give you for the expected income for 2014.
How's, like, what do you mean?
So, so what I did is I subtracted the expected income for 2014 from 2013 from 2014.
Yeah.
So at the end, what I had as the difference between those two expected incomes was delta parentheses minus 1 plus p close parentheses.
Delta times 1 minus p?
Yeah.
Okay, you're very, very close.
Oh, really?
Yes.
Well, I actually had, so did you do the expected income for 2013 minus the expected income for 2014, or you did it backwards?
No, it's 14 minus 13 because you're finding the difference between the two, the change.
Right. Yeah, that's what I did. And what I got was minus delta plus p times delta, which if you factorize, it's delta times minus 1 plus p, right?
All right, let me double check this because I did a lot of it in my head. So let me just, I'm whipping up my whiteboard here real fast. I have all of this written up on a homework that you can access online if you want to see.
Okay.
I can send you a link. Is that?
Yeah, that would work.
Because I type all my homework up on a online web thing.
Okay.
So I will send you that link in our group chat. So anybody who looks at it later can take a look.
Yeah, that would help. Okay, I got it.
And it'll also, I think it'll reflect my edits as I do them. I sent you just a read-only link though, because I don't want you all messing with my homework.
Right. Okay. Whoa.
Look at the right-hand side, not the left-hand side.
Okay.
The left-hand side is the code. The right-hand side is the actual document.
Huh. Do you do this just because that's how you take notes, or?
No. So in math, you use writing language called LaTeX, which basically is how you would like make a math textbook. That's how you would type it out, getting all the
Oh.
fancy symbols and junk like that. And so I had to learn that for a bunch of my proofs classes. And so it's just now whenever I do something that involves math, I do this because it makes it look fancy and official.
Right. What I do, I just insert formulas from Word.
Yeah, I can't handle that.
Yeah.
I can type so much faster this way.
Yeah, that's true.
So let's see, the expected income of 14 is P times the sick income plus 1 minus P times the healthy income, right?
Yes. I
Yeah.
got the exact same result for, okay, I see.
And we're doing P IS plus 1 minus P I H minus delta minus P times IS plus 1 minus P times IH. Okay, I know the P times IS I'll cancel, so we'll just ignore those guys.
So why are we doing that? Sorry.
Who, what?
So are you, what are you doing right now?
I am writing out my board. I have, I've wrote the expected value for the expected income in 2014, and I'm subtracted from the expected value from 13. So the expected value for income in 2014 is P, which is the probability you're sick, times the income when you're sick. And you add to that 1 minus P times the quantity IH minus delta, because that's the probability times the income at that point.
Yeah.
That's for 2014. And then subtracting that, and subtract out the same thing, but for 2013, which is the exact same thing, just not with the minus delta. And so I'm just figuring this all out right now.
Okay.
Because I just want to double check, because I could have missed a negative sign when I was doing this in my head. So I'm just writing it out for my first time.
Okay.
So give me 1 second, please.
Yeah, no worries.
So we've got IH minus delta minus P times IH minus delta minus IH plus P times IH. I think I goofed. 1 second. It's a lot of parentheses to keep track of.
Yeah. The result that you had for that equation that you're talking about is the same one that I got.
Oh, we got the same thing?
Oh. Yeah. So you say, let me read what you put in your homework. You said, if we let P equal probability of being sick, we have that the expected income of 14 minus expected income of 13 equals 1 times, parenthesis 1 minus P close parenthesis times minus delta, which is minus delta plus delta times P. And that's what I...
Okay, so I think I might have just misheard you then, because I thought you left off the negative and I was like, oh shoot, did I drop a minus sign somewhere?
Oh, I see. No, I think we're good.
Okay.
So is that the difference then? Is that the answer to A?
Yeah.
Okay. Yeah, so we got the same thing. So now for part B, do you have your book with you, or would you like?
Oh, I've got the homework up there, and the homework problem is written right there on the homework. I have the entire homework transcribed onto the paper.
Oh, that's right. Okay.
that's another habit from proofs class. That was how we had to have our homework written, so that the homework could function independent from the book.
Okay. So assume that a local insurance firm designed an ideal insurance coverage. Okay. So when it's asking how will the premium R change, if at all, what I was thinking before looking at your answer, what I was thinking that we needed to do is use the equation that it's R equals P times Q.
Yeah.
Is that right?
Yeah.
Okay. So what I was thinking is that after using that equation, maybe we would need to solve for P in our previous equation and put it back in the one that I just told you.
No, that's not, you don't have to go that far.
Okay.
If you remember from earlier, the point of insurance is to equalize two quantities. It's to equalize the income when you're sick as compared to your income when you're healthy. And it turns out both your incomes in each situation will be less than, well, your income will be less if you're healthy, but greater than if you're sick. So there's an income in the middle somewhere where they both will be met through this insurance. We would call that I prime.
I prime of, let's see. Yeah, is that in page?
Let me whip my book out real fast. That's page, one more page, 132.
132. Okay, so the expected income prime equals expected income when you're sick, which is the same when you're healthy. Okay.
Yeah.
So that's what the individual wants to achieve, right?
What was that?
That's what the individual wants to achieve.
Yeah, with insurance, that's what the individual will be set up with in the actuarial fair insurance.
Okay.
So afterwards, their payout when they're healthy will be something, and their payout when they're sick will be something.
Sorry. No, sorry, go ahead.
Yeah, so we know that I prime sub H and I prime sub S, the income with insurance when you're healthy and the income with the insurance when you're sick have to be the same amount.
Right.
And so we know from 2013 what all those quantities are, and we know that's all healthy. And so now we have to decrease something. We decreased I sub H in 2014, but his sick income stays the same.
Right.
And so there's a whole bunch of algebra you can do. Let's see.
But the main point, so what you want to find here is, let's see, how will the premium R change, if at all? So you want to solve for R?
I wouldn't solve for either one. I would look at what happens to his health insurance. What would it look like in 2013 if you set up those equations? What would they look like? And you can see right there in the book. You would have on one side of the equation, you have IH minus R. I added a 13 for the year 2013. So IH 13 minus R. We know that's equal to IS 13 minus R plus Q. Okay, and if he has actuarially, excuse me, that's fair insurance in 2014, then that same equality has to hold. IH 14 minus R has to equal IS 14, or 13 since they're equal, minus R plus Q.
Okay.
And so you would take your 14 numbers and then convert them to something that you do know, which is 13 numbers.
Sorry, say that part again.
So you know we're trying to figure out what's going on in 2014.
Correct.
So we write out the equation for 2014, which is IH14 minus R equals IS14 minus R plus Q. But we don't know a whole lot about what either of those two numbers are.
Right.
IH14 and IH13. But we do.
IH14 is IH minus delta, correct?
Exactly. And we also know IH14 is the same thing, or IS14 is the same as IS13 because his sick income does not change.
Yeah.
So substitute both of those things into the equation, and you now have, I have it written down here, IH13 minus delta minus R equals IS13 minus R plus Q.
Okay.
But you know from earlier that IS minus R plus Q is equal to IH13 minus R.
IS, sorry, IS minus R plus Q is equal to IS.
Is equal to IH13 minus R only by itself. We know that from last year. So that extra delta throws things off.
Right.
And so
Okay.
you have to then change some, you have to change some numbers and figure out, okay, what changes?
Okay.
What has changed? And if you look at that equation, you'll see that IH13, or the R's on both sides can cancel out. If you change an R on either side, then it's going to cancel out because the other side's R will change by just as much.
Okay.
So changing R does not make up for that discrepancy. Because there's only two numbers in this equation we can play with. There's R and Q.
Okay.
And if we change R, well, it just changes by the same amount on the other side. So changing his premium does not make up for, does not balance the equation.
Okay.
So the only thing we're left with to change is Q. And so we have to figure out by how much does Q change? Well, Q changes by a little bit, and so Q decreases because the point of Q is to raise up his sick income to match the level of his health income or close to it. But since his health income fell, it has to raise it less.
Okay. So Q is the payout, correct?
Correct.
And from what I'm seeing, so what you had is, to find this, we restate that, just a second. Okay, so you said IH13 minus delta minus R equals IS minus R plus Q. And then you, like you were saying, you can cancel the R's, correct?
Yeah.
And you would end up with IH13 minus R equals IS minus Q.
You would have IH13 minus delta equals IS plus Q.
Right. Sorry, I said it wrong.
Yeah. Or you could even cancel it out even more. Yeah, you can't get to it strictly mathematically. You have to reason it out a little bit, which is why I abandoned solving for something. But from that setup, you can see that if R raises or lowers, it doesn't change the equality at all. Because if I increase R by any amount, it will be increased by the exact same amount on the other side.
That's right.
But if I change Q on one side, the other side doesn't change at all. So the only way I can balance these two equations, because currently they're unbalanced, is by changing Q. Well, what happened to our left side? Well, our left side is now smaller because we're taking away a delta, which means we have to take away that same amount from the other side. So your Q decreases by delta.
Your Q decreases by delta.
Yeah, so your new Q, your new payout would be the same decrease in his income, which is delta. And that's how the equations would become balanced.
So, okay, would you mind repeating that last part?
Yes. So let's see. The reason I started out the way I did was to show that with his new income change, that one of these two variables needs to change, or at least one of these two variables needs to change. And so I showed a contradiction.
He's more sick now in 2014.
It's not he's more sick. He just makes less when he's healthy.
Okay.
So he just got a pay cut or something.
Mhm.
And so I showed that if you kept R and Q the same from last year,
Mhm.
that things wouldn't work out. His insurance would not be actuarially fair,
Mhm.
which means we know that either his R or Q needs to change.
Yeah.
And then we established that if you change R, that doesn't solve the discrepancy.
Mhm.
The left side of the equation is still smaller than the right side of the equation because of that little pesky delta.
Mhm.
So we know R remains constant. So then we have to play with Q. Well, how does Q change? Well, since that delta is there, if we just subtract delta from Q, then that balances the equations out.
Mhm.
So a new Q, the new payout would just be the old payout minus delta.
Uh-huh.
And that's how his insurance changes. And that makes sense because all Q is the payout for when you're sick. And the payout is meant to make up for your lost income when you're healthy. And if you're making less income, then your payout should also be smaller because it has less to make up for.
Mhm.
I go on to explain further that the only reason R would change is if your chance of becoming sick changed. R is meant to compensate for how likely you are to get sick, whereas Q is made to make up for the difference in your income when you do become sick.
Hmm.
That's what each of those moving parts does.
Is it just, well, okay. What you pay when you are healthy, right?
R is what you pay always. R is what you pay to have insurance.
Mhm. Okay. I will look at your notes because I don't understand very well. I mean, I understand the math, but I don't understand what you just said about how, like, if you subtract delta from Q, it would make that Q lower, so you would have IH13 equal IS13, which is what the individual wants, correct?
I'm sorry?
So what I understood is if you subtract delta from Q, you would equalize the equation, so it's IH13 equal IS13.
I
But you
prime H13, it goes I prime S13.
I prime.
Yeah. Prime is your income after insurance applies.
Mm-hmm.
The I's without the prime is how much your income is before insurance.
Okay.
Let me add a line real fast. That might help a little bit. Let me find out my code here real fast.
Mm-hmm. Maybe after I read your explanation, it'll make more sense.
I really don't want to write this out. Can I try to explain it one more time, a little more mathy? Would that be all right?
Yes.
Okay.
Do you want me to look at a specific equation while you do that so it makes more sense?
Yeah, so that equation we were looking at right now with the IH13 minus delta minus R equals IS minus R plus Q.
Okay, yes.
Okay. There's one other equation we know from earlier. Since we know his insurance before is actuarially fair, we know that IH13 minus R is equal to IS minus R plus Q. We know that's a fact and that's true. So this equality down here that I just told you to look at is not true.
Yeah.
If we were to subtract, if we were to cancel out both sides, we could cancel out IH13 minus R and IS minus R plus Q, which would leave us with negative delta equals 0, which isn't true.
Yeah.
That's a contradiction, and that's what we're trying to resolve.
Okay.
And so I have so the right side of my equation is heavier than the left side of my equation.
Yes.
And so we're trying to figure out, okay, I have two numbers I can play with, R and Q. What can I do to these numbers to make it balanced? And I first thought, okay, let's go with R first. What happens when I play with R? What happens if I make R smaller? Do they become balanced?
They just get smaller at the same rate.
Yeah, so changing R doesn't change the balance of the equations at all. So changing R doesn't do anything. We still have the same problem. So R doesn't need to change. We leave it alone. Okay, now what about Q? What happens when I change Q? Well, what happens if you make Q bigger?
The right side gets even bigger.
Does anything happen to the left side?
No.
Okay, so we know the right side's already too heavy. So if we make it bigger, that kind of makes the problem worse, doesn't it?
Yeah.
So what happens if we take things away from Q?
Then it would get more even.
Yeah, and if we were able to figure out exactly how much, then, well, we know the left side is Q lighter, or is delta lighter. So if we take away delta from Q, then all of a sudden we have tails.
Yeah.
Which means we now have a fair insurance with premium R and payout Q minus delta. And that's how you would come to what fair insurance is. And I probably should have explained that and written that out, but I got lazy.
Okay, that makes sense. So when you say Q minus delta, that delta is, let's see, how does that work? It's just the variation of the healthiest state of the individual, correct?
Yeah, at the very beginning, his income in 2014, I missed a 2 there. His income in 2014 is IH minus delta. And they don't tell us what delta is, so we have to just leave it as a variable.
Okay, so I think I'm getting this. So what you're saying is that to make the insurance in 2014 that's a hard word.
Actuary, yeah.
Actually fair, then you need to subtract that delta to Q, and Q is the payout that the individual gets, but it wouldn't be fair if he gets a higher, or let's see, a higher payout if there was that delta change in his healthy state. Is that correct?
Yeah, his income fell, which means his payout should fall too, because the whole point of the payout is to make up for lost income. Okay,
that makes sense.
Yeah, I should figure out how to say that word actuarially, because that's what I'm trying to do for a living, is be an actuary. So it seems like a word I should figure out how to say.
Yeah, actuarially. That's interesting. Okay, that makes a lot of sense. Thank you so much.
Yeah, not a problem.
And did you do C as well?
Yeah, it's right if you scroll down.
Let me see. Oh, there it is. Okay, so let me look at it. Is it okay if I read it?
Go for it.
Okay, suppose J finds a stipulation in the fine print of his contract that the premium and payout cannot change for 5 years. Okay, the firm gnashes its teeth and admits it cannot legally change the contract set in 2013. Okay, describe how full and fair this contract will be for J in 2014. So, from what I understand is the individual had his actuarially fair insurance in 2013, and they cannot change that contract for 5 years, right?
Correct.
And the company is not happy at all because the individual, even though his it will be full, but it wouldn't be fair.
Yeah, I could see. I'm trying to remember what the exact distinction is.
So let me look at it.
I know
So-
full is what makes up for the difference in your income. A partial insurance would make up for a portion of it, but not all of it. And then fair is where the company doesn't make a profit, or I guess nobody makes a profit off of it. And unfair obviously would be if they make a profit, they make some money. Although in this case, it's a little weird.
Yeah. But does that make sense? Do you agree with me, or do you have something else?
You said it was full and unfair?
Yeah.
Okay, in what way?
So I think it's full because it's still a, let's see. Let me look at that table. Just a second.
Oh, hey, there's that table. I should have looked at that. That is a
Yeah,
thing.
there's a, I'm looking at it and I'm trying to understand how to read it.
So if you want to know if it's a full or fair insurance, so for something to be full, Q equals IH minus IS.
Okay.
And if it's fair, R equals PQ. Unfair is when R is greater than PQ. And then a partial insurance is when Q is less than IH minus IS, or the difference in your incomes.
Okay. So in that case, it would be fair, correct? Because they couldn't change the, let's see, let me think through it. So in 2014, Jay's income decreases. Therefore, the payouts should decrease as well.
Right.
But they don't.
Right. They can't. So
they can't. So that means that Q is greater. Well, that's not even an option here.
yeah, it's not an option, unfortunately, but that is what happens, and so that's why I say it's unfair, but not in the way that they phrase here, because this isn't a normal situation.
Right.
So
because
there's
that could happen. It wouldn't, like, an insurance company wouldn't do that to itself.
Yeah, well, they probably wouldn't. There's some more to this, and that will probably help this discussion if you want to keep finishing off the question here.
Yeah. Sorry, I don't think I understood that. What did you say?
So the rest of there's more to the question than just if it's full and fair.
Okay. So all right. So it says. What do you have? Okay. Would Jay prefer to be healthy or sick? Is that what you're talking about?
Yeah.
The rest of the question?
Yeah.
Okay. Would Jay prefer to be healthy or sick, assuming he buys a contract and that his utility is determined by his income level? I would say he would prefer to be sick because his payouts will be greater even though his income decreases.
Yeah. Yeah, and go ahead.
You said Jay will prefer to be sick in this scenario as he will be earning more money than while he is healthy.
Yeah, because and I have the mathematical justification right there. When he's sick, he earns IS minus R plus Q. And when he's healthy, he earns IH 13 minus R.
When he's healthy, you say?
Yeah. Which is his, well, that's last year when he was healthy, he would earn his regular healthy income minus the premium for buying insurance. So IH 13 minus R. This year, he's earning IH 14 minus R. Well, we know IH 14 minus R is smaller than IH 13 because his income this year fell. Well, as the year before, both sides of the equation were balanced. Well, we just substituted something smaller on the right side.
Yeah.
And so since it's smaller, obviously you want to pick the other side, which is when he's sick.
Uh-huh. Yeah.
So since he's out the payment anyway, he wants the Q because that puts him at a higher income.
Yeah. Despite that his income at the healthy state has decreased, which if everything would work in favor of the company, his payouts
Yeah.
decrease, correct?
Yeah.
Okay. Yeah, that makes a lot more sense. Sweet. Thank you so much.
Yeah, not a problem. I love doing this.
Okay. Are you gonna be a teacher?
No, okay, so that's my passion. I love to teach. I want to, but I don't feel like I can support a family on a teacher's salary.
Okay.
We just don't pay teachers enough in America. So
My
I'm
husband
studying.
wants to be a teacher.
What do you say?
He loves it. My husband wants to be a teacher.
Yeah, that's my dream. I love tutoring. I love helping. I love answering questions. It's like my favorite thing to do ever. But I couldn't feel comfortable doing that.
Right.
So I decided to study and be an actuary instead.
Okay.
So.
Oh, what is that? Sorry, I don't know.
No, it's fine. Most people don't know. An actuary is somebody who does risk analysis, usually for like insurance companies.
Okay.
So you know what we're talking about right here with how likely this is, like exactly this stuff we're talking about here is what I would like do for a living.
Okay, that's cool.
Yeah, so it's basically I would try to. You ever buy car insurance before?
No.
Or any kind of insurance, I guess.
Yeah.
So you know they have you like fill out a form and they say, you know, are you a smoker? Have you smoked in the last 5 years? And blah blah blah. They ask you a whole battery of questions. Well, those battery of questions categorize you under a certain amount, and then they put all that information into one big equation, and that spits out how much you are expected to cost the company over a certain period of time.
Okay.
And then that's how the company decides how to charge you. Because they want to charge you at least as much as they expect you to cost them. Well, an actuary is somebody who sits down and figures out those rates. They figure out how much will somebody in such and such a situation end up costing the company in the long run.
That is cool.
Yeah, it's a lot of statistics and things like that. They also do some other weird things like, okay, us as an insurance company have taken in so much money. How do we make sure we manage this money so that if so many people decide to make claims with their insurance all at once, we actually have enough cash on hand to pay them all. So they also manage the money supply, just stuff like that. Or the government will hire them to, like for FEMA, there's a hurricane that comes through. How do we assess how much to cover, how much resources do we put in New Orleans versus middle of nowhere, Montana?
Okay. That is very interesting. You studied applied math, correct?
Yeah, I'm an applied math major, yeah.
Okay. That sounds very interesting.
There's a lot of actuaries, though, study as economics people. So there's a lot of overlap.
Okay.
But the first actuary, because there's a bunch of certification exams you have to do, and the first exam you would take involves a bunch of multivariable calculus, which is, it sounds scary. It's not as icky as it sounds, but it's still annoying.
Yeah, that's very cool. Well, awesome. Thank you so much.
Well, thank you for setting up the call and doing that. And like I said, if you ever need help, or I guess anybody who's listening to this, if you ever need help, just let me know.
Yeah, I will post if you're okay with it, I will post it to the group chat so they can listen to the recording.
Yeah, that'd be perfect. I'm fine with that.
Okay, sweet. So tomorrow at 1:30, right? For the group quiz?
I guess that's what you all said. I was in a movie while you were all deciding, so.
Okay, yeah, I think it's 1:30.
All right, yeah, okay.
Okay, perfect. Thank you so much, Pierce.
Yeah, no problem. Have a good one.
You too. Bye-bye.
Bye.